are not satisfied with the named matches here, what you can do is you can use our UI to retrain a model to recognize names better in the context that you're using it in. The way you would do that is you would select the new NER model wizard right here, and you can train it in two different ways. You can train it using supervision or from existing training data that you've either generated or created yourself. And I'll show you how that training data looks in a bit after we finish this particular wizard. Here we can define, again, the parameters for our builder. We can select the model that we'll use as the base for our training. So I'll select the NER bin model, NER person bin model right here, which we've used to find names previously. We can specify the annotation label. This is just the label that will be used in the annotated version of the training data. The actual algorithm doesn't care what you name this label. This is just for human view to see that, okay, what I've annotated here is a person. But again, named entity recognition can be used to annotate all sorts of things, including organizations, dates, things of that nature. What I'm doing here is I'm selecting the documents that I'll be using to perform the training. And I actually I partitioned the movie lines into two different files, one that contains the training data and one that's going to be our test data, just to demonstrate what improvements we can see. So I'll select the training data first. Here we can see that we have 90,000 sentences that we've extracted from here, and this is it's going to be tokenized as well in the way that the named entity recognition algorithm expects it to be for the training purposes. You can select multiple documents. I can even add other formats like PDF documents just fine. I demonstrated this particular capability using a PDF manual of our Field Shield tool. Anything we can search through basically in our dark data discovery wizard, we can also use as training data. So you don't have to actually extract the raw text yourself. So fairly convenient in that regard. So here's the crux of the wizard. This is the supervised training portion of it. And what we're going to do here is we're going to select the search button to begin a search through our documents that we have to find named entities within. So what it's doing now is it's going through this movie lines training text and finding names based on the pre-trained model that we loaded previously in the first step of this wizard. And we'll just see how effective it was at identifying names. So you can see a lot of names here: Clint Eastwood, Blaze, correct ones. You can also see instances where things contain part of a name, but then text that isn't part of a name. So what we would do in those cases is we can actually select that entity and click Edit. And you can select the accepted entities from the table here, and then select a portion of the sentence where a name appears and just click Add to select only that name. You can do things like split up names into two different ones. So if E question mark isn't part of a name, we can just say Block and Mandela, or we can remove Block entirely and just say Mandela. Some things are not names at all. So mom, for example, if you look in the context of the sentence where it appears in, mom is just mom. So it's not a named entity. And what we can do in that case is we can move it from accepted entities into blacklisted entities by double clicking. A blacklisted entity is basically an entity that was below the reject threshold that we can specify here. So every named entity has a particular probability that's attached to it for how likely the model thinks that this was a name. So you can set this reject threshold higher so that it will place more names into the blacklisted entities every time you search. But you can also move things in and out of accepted or blacklisted entities. So for example, we know that Billy and Lindsay here, and Paul, Anderson, Bill, Mitchell, probably Price, Roos, Max, Ryan, Carroll, right? All of those are names. So we can move them over to our accepted entities instead. What we can also do again is move things into the blacklisted entities from accepted. Daddy is not a named entity. And so we go through this whole process of actually making sure that what we What we have here are just named entities that we're interested in and not false positives, which the model identified. It's fairly hard for it to be automated where you can say with exact certainty how a named entity should be annotated within any particular sentence, right? Here we've designed a tool in essence that allows you to simplify this process by using a pre-trained model that you had previously to help you out by pre-annotating most of it for you and you just check in its work. If you wanted to write something where annotate things based on some rules that you want to define, then you can also generate your own training data in that sense and then load it up through our wizard here to generate the associated model for it. Once you say, for example, went through this whole entire process, which took me about 30 minutes, what you can do is go ahead and train the new model on the accepted entities that you annotated. So it'll take the accepted entities, it'll go through the original training data that you provided and annotate those entities there automatically for you. Put that annotated text file through the training process that's going on right here. So again, this is a way for the business user to automate that particular portion of the training without actually doing any form of programming on their end. If you wanted to have some special rules for how you want things to be annotated, for example, annotate anything that follows my name as a person, you can write custom scripts that can go through the training data itself and add the annotations for you. But we can't think of every possible scenario where you can add those sorts of automated scripts. This is the most general way that we can think of that can be used to retrain a model that is simple enough for a business user to understand, but also extensible enough that a programmer can also add their own sorts of annotations to the training data. You can perform the search and training multiple times. Once you've retrained the model, you can perform a search with the new model to see if it identifies any more accepted entities within. And this way you can iteratively train that new model and see what sort of names it comes up with. Once you've gone through that entire process of search and training and you're satisfied with your results, you can then go ahead and finish this particular build of the model and generate the model. And since we've selected the training data as well. Here is the new model folder. It has the binary file that's actually used as the NER model by the algorithm, and it also contains the training data. So if I open it up, so this is the training data looks like. You can see here you can have an annotation where it annotates the name. So start, person, and end. That's how the annotations look like. You can see that all the tokens are tokenized, so there's space between the tokens. That's just something that the algorithm expects in order to perform the training. If you were to provide your own bulk training data, you have to be able to tokenize in the same way and split things into sentences the same way and perform the annotations the same way. And there are tools available, command line client tools through OpenNLP that can perform that. Or you can also use our tool to do the supervised training yourself if you're more of a business user, not technically savvy with the command line clients or regular programming, general programming languages. What we'll do is we can modify our existing search configuration file. What I'll do is I'll copy over the previous search results that we have into a separate folder here so we can have that for comparison. I'll go ahead and modify the search configuration file slightly. I'll remove the AWS source because we no longer really need it. We demonstrated that we could access things there. What we are more concerned with is seeing if our new model that we've created can identify named entities better than the original pre-trained model. So here under search matchers, I can edit the names NER matcher. I just click create. I'll create a new named entity recognition model or data class with the one that I pre-trained. well, that I trained myself rather. All this NER. I'll just keep the same encryption rules, so go ahead and save that, and I'll perform the search again. In this case, in the search and remediation again. It should run up slightly faster now that it's initialized all of its resources the first time we ran. So here are the new search results with a new retrained model. What you can see here again is more names that were identified. You see a lot less Oz. If I go back to the original search text file, one of the first things I think we see is things like doctor, right? Doctor was identified as a name, even though it wasn't. Doc is also a name, not is a name. New search model that we created is a bit more conservative in that regard, in that it has less false positives. It also identifies a little less number of names than the original, but that's because we probably are going to need more training data to actually create a better model in that regard. Even though you retrain that model that might be smaller than the original pre-trained model, it won't have more false positives. Instead, it'll just have more named entities that are relevant and less false positives. But if you want to have a bigger range of named entities closer to what was available in the pre-trained model, then you have to train it with more and more data. You have to partition the data in such a way that two CLI processes don't access the same file at the same time. Applying the filters, that's right. So include patterns to exclude patterns. And as I said, we are currently in the process of looking into REST APIs, which allows for scaling this out horizontally across the network, in essence. So multiple machines that can be working on performing the search and their mediation. And all you have to do is just send your queries over to there with your documents and get back the results. You can actually define custom masking rules. You would just have to know a bit of C or have us do it for you. That way you can create custom masking rules that can then be loaded dynamically at runtime by SortCL engine. There is a header file that ships with SortCL, which contains the basis of what you need to implement in order to generate a DLL or a .so file that will be dynamically linked at runtime, which contains the masking rule that you wish to apply. So we do provide an integration for DarkShield with Splunk, which can do some of the reporting for you. We do have a couple of blogs that may be of interest to you to check out to see if that could match your use case. You can also monitor the runtime through the regular, let's say I execute this search, it tries to run it here, and you can see all of the jobs that are currently running in this particular progress tab. Yes, if you provide a pseudonymized set file that has a mapping from one name to another name, yes. And we also provide tools if you have those names within a structured source like database table. We can create one where you scramble, in essence, the names there and provide a mapping to a scrambled set of names. And that will able to apply consistent masking. In those cases, we usually recommend just using format preserving encryption again, because you don't have to keep the set file, this unsecure set file somewhere stored, which provides the mapping. Instead, you just have to keep track of your passphrase, which was used to do like a format preserving encryption, for example, or any source of encryptions. Unstructured currently no, because due to the nature how it's remediated across different file formats, it might not be as simple. Also, those files could be modified since the last time that it was performed the search and masking, so there are other considerations to take in.
So because it's more difficult to decrypt, not impossible, but not as automatic as it would be in the structured world. In the unstructured world, you'll need to restore the original data. Then what, Dimitri, would recommend targeting an alternate directory rather than overwriting the original source, yeah? The mask, for the encrypted data, so that they could use the encrypted stuff in one location, but they would still have the original if they needed it, rather than having to go through a more difficult decryption exercise on the single
Yeah,
source.
if you were to quarantine your original sources and archive it in a very secure vault so you can obtain the original, that'd be more effective, I'd say. And then
It would
only
be easier. than trying to decrypt the single remaining source that's been encrypted in the case of unstructured data. Like I say though, with structured, it's more straightforward because you just simply apply the reverse case and it goes through, and it's just much easier to locate what's been encrypted when the data are structured. So it's a much simpler sort of one button operation than it is when you're having disparate sources in different formats and different silos.
Like it's conceptually possible, like for text files or Word documents, to do the reversal in DarkShield. But again, it just gets harder when you're doing things for image formats, where we do a black box redaction, for example, where that's just not reversible in any given sense. Or for PDFs, it could also be a bit complicated, just because you might have encrypted something but found that you couldn't use the original font because that wasn't available within the original document to begin with, so you defaulted to Times New Roman, and now you're trying to decrypt back, so you won't get the exact same document back. You'd get whatever was decrypted in Times New Roman instead of the original font.
Right, because depending on the search methodology that you're employing in an unstructured world, it may not be possible to find what's been decrypted in the same way that you found that which was unencrypted in the first place.
Yeah, like we can certainly store the encrypted portion of the text appears and then use that to decrypt it. But again, we have no assurance that it will be
Same
the
place.
original. Yeah.
Because things tend to shift in redaction operations, right? So sometimes, you could have encryption happening at the same time you're doing redaction, which changes the offsets, the byte positions that were recorded. That's why it's easier in the structured world because those positions never change.